Hey there, how's it going? I always have to wait because I never know when I've actually gone live or not. But it turns out I am live, so it's good. I'm Pete Gallagher. Normally I'd be on my own Twitch stream doing IoT stuff, but it makes a lot of sense for me to come onto the Azurist channel and drive all our efforts into this awesome channel. So obviously hello to Liam and Jonathan that I'd normally be on with as well. But today I'm going to be having a look at this little device. So this is the new Raspberry Pi Pico, which is the first microcontroller Raspberry Pi that the Raspberry Pi Foundation have made. Really cool device. So they've made their own silicon, the RP2040, tiny little 7x7mm microcontroller, and it's just come out today. I actually got mine on the front of Hackspace magazine, which we have here. So if you're lucky enough, if you nip down to the newsagents, you might find that there's still some of those available. I'd be surprised the number of people that have got sad faces on Twitter because they've sold out already. I kind of felt like that when the Raspberry Pi Zero was given away on the front of, I think it was the Magpie magazine. I missed out on that. But yeah, so it's quite cool. It's cool that they've made their own silicon for this as well. So they've got a lot more control, I guess, over it now. If I switch to this my shared screen here, then this is the release blog post on the Raspberry Pi website, and there's some information about the device here, including the fact that it's an RP2040 down there. Scrolling past some of these bits of information, there's the specs for the device down here. It's got 264 kilobytes of RAM, and that just reminds me of, I'm old enough to remember the ZX Spectrum and the 128K ZX Spectrum in particular, and of course this is basically a 256K device, so that was nice. So remember kilobytes? Yes, most certainly do. Something else that I found interesting was this 16 PWM channels here. So obviously we can drive things like servos with PWM. So imagine the sort of robots that you could make with 16 PWM channels. That's I quite like that idea. And I see people making cars and things already, motor drivers and stuff as well. So that's going to be pretty cool. I quite like that. And obviously there's a whole heap of other stuff. There's TensorFlow Lite, Peter Warden's TensorFlow Lite framework. So that's pretty cool. I like that. We program it either with MicroPython or C or C++. And I'm going to be looking at MicroPython today, which I don't spend a great deal of time in, funnily enough. I'm normally a .NET programmer. I'm a Microsoft Azure MVP. So most of my IoT work tends to be in the Azure stuff, and either in Node or in C# in .NET. So yeah, I'm just going to make sure that if there's any chat or anything like that, I'm going to cope with that, which is fine. So that's good. So obviously, yeah, if you've got any questions, then I'll try and answer them. But I'm new to this too. I've just got this today. So I mean, you can see sort of above my head up there, I've got it. The header's soldered on, and I've got it put into a little breadboard, and there's a circuit. So what I'm going to run through is this getting started guide with the Raspberry Pi Pico. So this is on the Raspberry Pi website. And in fact, I'll paste this link in the chat if it lets me. Okay, I'll do it on here. I'll put it in a little minute. Oh, the chat's there, that's fine. You never get everything you want. Hi, Carl, how's it going? Weirdly, the chat I've got on my desktop's not working here, so yeah, Hackspace is still offering the free Pi Pico. That's a really good point. So I mentioned the Hackspace magazine earlier. They've got a really good offer where you can get 3 issues for 10 quid, which is a bargain, really, because it's such a good magazine. But on top of that, there's a link that you can go to that I will also put in the chat, that you can get a free Raspberry Pi Pico with it. So let me just put that in the chat as well, so you can have that. There we go. So yeah, if you hit that link, then yeah, free Raspberry Pi Pico with your 3 issues there. So 10 quid for 3 issues. These are normally 6 quid each, those magazines are. So to get a free Raspberry Pi Pico and 3 issues for 10 quid is an absolute bargain. So well worth doing. So that's cool. So this introduction, you might recognise that. So this circuit here is what I've copied on here. Whether I've got the LED the right way round is another thing. I've been doing electronics for years and years, but I still end up having to pick the LED out and swap it around. The other thing is, when I was putting this in, it was quite tight to put things in, and I noticed that some of them are tight and some of them are loose with these wires. So I've got some spares just in case, some better ones. So we'll see if I can get to the point where I'm flashing this LED today. It probably won't be a massively long stream, but I will just go through all of the things that this introductory material is calling out. So it's got what we need here. So obviously the Raspberry Pi Pico with the soldered headers. I'm just going to zoom in just a little bit further just to make sure that it's okay for people to read. We need a computer and a micro USB cable, which I've got ready, and the other end's plugged into the PC, and I'll plug it into that in a minute. Such components like a button and LED. I'm only going to do the LED and the resistor today, and then perhaps I'll do some more complicated stuff later. And a breadboard and some wires, which I've got. And yeah, if we wanted to, we could plug it into an external power source and power it and have it run autonomously. So yeah, we're going to be doing MicroPython using the Thonny, and we'll have to put the firmware on there for MicroPython. So I'm not going to go through too much of what we'll learn because we'll do that as we go. So yeah, that's what the Pico looks like in drawing form, and then this is the assembly process that they've got there. So stick it straight in the breadboard, and then it's actually telling you to plug it in there, but then they tell you don't plug the other end in. So this is the pin out, so you can see. I'll zoom in a little bit further for that if it lets me. Oh no, that's about as far as it's going to let me zoom in. So, but yeah, a bunch of GPIO like you'd expect on a Pi, including I2C. Actually, there's plenty of I2C on there, which is nice. In fact, I'm not quite sure why there seems to be some repetition. It looks like they're the same there between those two blocks there. So whether or not you can just assign them, which I guess you can, which is quite cool. So UARTs and things like that, and then PWM on a heap of these as well as ADC, which is nice. I mean, one of the benefits of using the microcontroller over something like the Raspberry Pi is that you can do sort of more real-time work on it. So when you're running the Raspberry Pi, it's a full-on computer, and you've got Linux running underneath it, and so timing is going to be up to the operating system at the end of the day. And I know you can put bare metal code on a Raspberry Pi, but these microcontrollers are designed for this sort of low-level work, almost like an Arduino. 10 Power 3 magazines offers UK only. That's a really good point, actually. But there is one for 12 issues for 90 quid. That's a really good point. So yeah, thanks for calling that out, Carl, and thanks for the question. So yeah, there's a little debug few pins on there as well, which I'm not entirely sure what it does. So perhaps it'll get called out at some point, maybe. So installing Thonny, which I've not done. So I have got the Thonny page open though. So Thonny is a really cool Python IDE. So I'm going to download that and get this installed. You can do it. There we go, it's doing it. And I'm going to keep that. Show more. Keep anyway. And then I can open that. Oh no, well I'm going to run it from my downloads folder and do it that way. Oh man, if everybody has to go through this to get it to run, it's going to be a bit annoying for people. There is nothing wrong with Thonny. That's just Windows trying to protect us, really. I am going to zoom in a little bit while I'm doing this so you can see what's going on. Install this. Yeah, I'm going to create a desktop icon. Let's do that. I'm glad this isn't going to take an hour to install, otherwise it'd be a very boring stream. So yeah, obviously you can for going and buying the the Pico, then if you're a UK person, then the Pi Hut or Pi Moroni or any of those sorts of places, they had stock first thing this morning. I've not looked to see if they've still got stock. Oh, good. I don't know if my stream went a bit funny then. It looked like in the stream there. I don't know if it went a bit odd, but anyway, do shout out if I'm stopping and starting or something like that. Oh, Zoom in. It's Zoom It is what I'm using. That's a free little tool. I'll show you. Zoom It. Okay. So you just run it, and then there's shortcuts. You can do Control and 4 or zoom in and keep the screen alive, or if you don't want to keep the screen alive, you can do Control+1. And I think you can also draw on the screen as well, which I really must look up how you do that. So I guess that must be Thonny installed, and it is. So that's good. And again, call out if something's too small on the screen, or I've not understood something properly. Then shout at me in the chat, and I'll try and go circle back and sort something out for that. So that should be Thonny installed. So I'm just going to power that up. Over here. So it's asking me some settings to get that installed. I doubt very much there's anything I need to do. I just click Let's Go. And there's Thonny. So I'm hoping that I can zoom in on this. I'm not. Just have a look. I can Control and plus for the font size. It said it was. Well, why isn't that working then? Control and plus is not Control and plussing. Well, the mouse wheel will work as well, so that should be good enough. Obviously, you're not going to be able to see these here very easily, but I can zoom into that in a little minute. Right, so let's carry on. What's it say we need to do now? We can use Thonny to write standard Python code, and we can type this into the main window. So let's do that. Let's just follow these instructions and make sure it's working. So type the following into the main window, then click the Run button, which is there. And we're going to need to save it. So I'm going to put that in my downloads directory for now. Thonny1. Hello world. Oh, good. Well, Thonny's working then, so I'm happy enough with that. Next, we can connect the Raspberry Pi Pico, which is the part we're really here to see. So if we've never used MicroPython, then we need to add the MicroPython firmware. So we need to do that. So we need to find the boot select button on the Raspberry Pi and press the boot select button and hold it while we connect the other end of the micro USB cable to the computer. So I think you should be able to see that in the image above my head. That should be okay. So I'll try that. So that's the boot select button there. I'm hoping that the Twitch stream will sort of catch up, but I'm going to press and hold that with one hand and then plug this in with the other. If I can get it to go in. I heard the Windows chime, and so I've got a device now. D:, has appeared, which is good. Puts it into USB mass storage device mode, and in the bottom right hand corner of the Thonny window we should see the version of Python we're running. So zoom in and go down there. So 3.7.9. It wants us to click that. And then we need this one, MicroPython Raspberry Pi Pico. Click on that. And then here it's going to want us to install the firmware. So let's do that. Oh, let's just move across a bit. Should be able to see that. I bet you've missed that extra piece that was going on there because I've zoomed in. Done, it says. So yeah, plug in the Pico with that boot cell and click install, and then that's it. So that should be done. So we can come out of that. And switch back. What's next? So we did that, and then we did the dialog box. You don't need to update the firmware every time, which is good. Next time you can just plug it into your computer without pressing the boot cell button. So it's not told us that we need to unplug it or anything to get this to work, so that should be okay. And the next step, you use Thonny to run some simple Python code on our Raspberry Pi. So that should have MicroPython is indeed selected down there. So actually it's right behind me, so that's a bit awkward. There we go, I'll move it across. There, so this is the menu that I clicked on earlier. Apologies, that was right behind me. And so look, we've got some options in there. In fact, what I spotted earlier was these two, so ESP32 and 8266. So they're two Arduino boards that come with Wi-Fi and Wi-Fi and Bluetooth in the case of the ESP32. So I really must have a go at MicroPython on those two devices. I've done plenty of C work on them, but I've never tried Python on them, so I quite like that. It's quite cool. So we've got to look at the shell at the bottom. We should see something like what we can see. Yeah, there we are. So that's that. Right, there we can see that Raspberry Pi Pico with the RP2040 device on board. So, by the way, I mean, Pi Moroni are making a whole heap of devices based on this as well. So that's going to be dead cool. A little gaming device, and there's an audio hat, and there's breakout board type things, and they're making some awesome kit. So do go and check Pi Moroni website out and check that out. That's yeah, I had a look earlier and I wanted to buy all the things. Now we can type commands directly into the shell. So type the following command and hit the enter key to see the output. So I should be able to do this. And we got hello. That was fast as well. So that round loop that it's going round. Actually, there's some round loop because I've got a monitor here with a USB hub built into it, and then another USB hub plugged into that, and then this plugged into that. So yeah, there is a round loop to go there as well. So that's cool. That one works. MicroPython adds hardware-specific modules, such as machine, that we can use to program the Raspberry Pi. So we're going to create a pin, and what we're going to do here is turn the onboard LED. So there's a little tiny LED up around here. So we can turn that on and off. So we can do this first. Import a pin. And then we can set that. This pin 25 must be the address for that particular pin, the pin number for that pin. And then we should be able to set it to on. And I can actually see that. So if I just go to this screen, then you should be able to see up near the USB there that is actually on now. So I like that. Everything is working, so that's good. Aside from the palaver of trying to get Thonny to install, everything actually seems to be working, which is nice. So should see the LED light up. So we can actually turn it back off again. So I'm going to switch back to the phone and me and then turn this back off while... There we are. So you can see that going on and off just by flicking between those two things. So that seems to work quite nicely. I like that. Good. So what's next? If we want to write a longer program, it's best to save it in a file. So using the shell is great, but in this step we're going to create an actual program to blink the LED on and off in a loop. So we're going to enter the following code into the main, into here. So that's fine. And then we can click the run button. I've already saved it, so it should just save itself to where it was and run that. Well, that looks like that just went once. So, just looking at the Pi Moroni website, just saw this. Wonder how long before someone makes a Stream Deck clone with that. Yeah, yeah, definitely. That's true. I mean, Carl's talking about that Elgato device, and what I've got set up down here is just a tab, and I've got an OBS remote app running on that. But it's nowhere near as good as one of those Stream Decks. That is what you're talking about, I think, isn't it, Carl? The cool thing about those Stream Decks is that they've got little screens in them, tiny little OLEDs. So buying a bunch of those would be high on my list of things to do. So I'd quite like that. So I don't see this. I mean, what am I doing here? Let's just stop this code. Oh, well, it's not going to... All it's doing is going to run once. It's not a loop yet. So click run. Actually... Click the run button. Thonny will ask you whether you want to save the file. Oh, see, because I've already saved it, then we didn't get that window as well. So I wonder, can I do new and try it in there, see what that window looks like. Oh, there we are. So I can either run it on this computer or on the Raspberry Pi Pico. So that makes sense. So if I click Raspberry Pi Pico, oh, now what's it saying? We can save it to the Raspberry Pi Pico. enter blink.py as the file name, so let's do that. Blink.py and press OK. So we did that. Now what? Lots of flicking around between these two things. Finally, to save your program to the Raspberry Pi Pico and run it, you should see the onboard LED switch between on and off each time you press the run button. So yeah, that's kind of what we saw, isn't it? So if I keep pressing that run button and we switch back to this sort of screen, then we should see, there we are, that's the LED turning on and off every time I hit run. But I think what they're going to do next is what I'm going to say. That's not very automatic, is it? So I'll switch back here. But we can use a timer module to set a timer that runs the function at regular intervals. Brilliant. So we can update the code to look like this. So we're going to add this timer in there. And then when the timer goes off, it's going to hit this toggle. And we're going to set that to 2.5, which I believe is probably going to be seconds. So every 2.5 seconds, it's going to blink the LED on and then off. So let's do that. Update that. And then run it. That's not 2.5 seconds then. That must be something else. That 2.5, because it doesn't look like it's 250 milliseconds either. So there you go. You can see the LED flashing on and off now. So I mean, this is dead cool. I mean, what's great about this is that I kind of always wanted an LED on a regular Raspberry Pi for this exact sort of stuff. And I think I actually asked Eben Upton when I went to one of the birthday parties why we didn't have an LED. And he quite rightly said, of course, you stick an LED on there, then you're going to use the GPIO pin up. And somebody's going to be annoyed because they might want that extra GPIO pin. So the fact that we've got an onboard LED there must just mean the fact that they wanted to keep this so small that there wasn't space for that extra GPIO pin to get pushed out to the edge. So they've just left it as an LED, which I like. I think it's really good because now you don't need to solder pins onto this. You don't need to put it in a breadboard, plug anything in to actually get it to the point where you know that it's working, which is really accessible. I like that because not everybody's got a soldering iron, apart from anything. I'm willing to bet that just like the Raspberry Pi Zero, we're going to get a Raspberry Pi Zero WH with the headers. So we're going to get a Pico H, I guess, with the headers already soldered on. That'll probably come sometime next week, I guess. So yeah, that's good. I like that. So what does it want us to do next? We can use the digital inputs and outputs. Perfect. So the circuit we've got wired up, whether it's correct or not, we'll find out in a minute. So this is just showing us what we've done. So from the pin out that we had before, this pin down here where my mouse cursor is, and I really should learn how to do the drawing in Zoom it. That's going to be ground. And this rail across the top, the blue rail that you can see there, that is all connected together. So that kind of signifies that what that yellow is all the way across there. So we're bringing a wire out there, connecting one side of the LED, and the other side of the LED is connected through this resistor to this GPIO. I think it's GPIO 15 down there. It's a really simple circuit. The current's going to come out of that pin and then sink down into that ground. So that's going to be quite cool. Elgato Stream Deck is sold out everywhere. I did have a look, and I think at one point it wasn't, and it was relatively cheap, and not that long ago actually. So somebody would make a killing if they decided they were going to make some sort of a knockoff for that. Actually, it's not that hard. All you need to do is configure the keyboard shortcuts in OBS, and then you could have a device not too dissimilar to this, but I think maybe a Raspberry Pi Zero would be better, that can act as a USB HID device, and then you hook your screens up to it and it just does key presses for you. So I did think about doing it, but oh man, I've got a lot of work to do. So so that was cool. So in this example, we've got the LED connected to pin 15, so that's right. If you use a different pin, remember to look at the pin number, so that's fine. So we can use the same code as we did to blink the onboard LED, but we can change that pin to 15. So I don't need to copy all of that. I can just change this to 15. And we can try running it. And it looks like my either I've not got it on 15, or my wiring's not quite right, or my LED's in the wrong way round. Which do you think it is? So I'm going to pull that LED out. and flick it around. And I heard my computer bing when I did that. So I don't know if I accidentally unplugged it when I did that. So that's interesting. Now when I'm plugging it in, I'm getting like it's plugging in and then immediately going off again. So let's just try that again. Interesting. It looks like it should be connected okay. I'm not getting the run up here as well. I don't know if you can see. If I zoom in, the run has disappeared. So it's like it doesn't know it's there. So I am just going to try closing Thonny, backend terminated. You stop, restart to restart. So how do you do that? Ah, stop, restart, backend. This button here. Oh. Ah, now I've got a plus, a play again. Check the connection, making sure the device is not in bootloader mode, or choose configure interpreter. Interesting. I'm gonna close this. I'm gonna disconnect my device again and plug it back in again. It would be slightly sad if I've broken it at this point. Let's try Thonny again and see where we get to. Check the connection. So, interesting. What can I say? I mean, unplugging that LED while it's on really won't make any difference whatsoever. So I can't see why that would have upset it. I'm going to try plugging it in bootloader mode again. Yeah, I'm getting nothing on there. I wonder if it's something in the device manager that's causing it. And I mean, that's why we do these things live. Let's have a look. See if maybe there's a driver that it doesn't like somewhere. Devices. Devices and printers. Device manager. And again, apologies for this, but so we've got an unknown USB device here. So I'm going to uninstall it. And let's see if that fixes the problem. So that was in this area here. I had an unknown device. So it's going to try unplugging it again now. Plugging it back in. So I'm not hearing that magical bing at this point. We've done that with oh, hi, Girls Into Coding. How's it going? Nice to see you. If you don't know who Girls Into Coding are, then go and have a look on the internet. They're a fantastic organisation. Go look them up. And in fact, let me see if I can do it this way. Look. Let me paste a link to their website in the chat. There. Go and support them however you can. Yeah, we'll use VS ISO Thonny. Hi, Helen. How's it going? Yeah, definitely do. So I'm hoping that I've not broken my device. So I'm going to try plugging it into a different port. I've got to be careful because, oddly, some of these USB connections are a little bit dicky as well. Still not hearing any bings. I'm going to plug it directly into my Surface. I don't know if you can still hear me. My webcam has decided that it's going to go on the fritz and stop working entirely. So you probably can't see me. I'm just going to be stuck there for a little bit. So apologies for that. But let me just see if I can plug this directly into my machine and see if I can get that working again. You don't need to see me to understand this. It's fine. Oh, I heard it. So I think it's the I think it was just the device it didn't like for some reason. So all right, well, that was a little glitch, and again my webcam's decided that it's going to stop, so I'm not entirely sure what its problem is there. I'll quickly just try this. So right, I'm going to paste this code in and do 15 here. And then I'm going to click the run button, and then we can click this Raspberry Pi Pico again, hopefully. And we still don't have an LED flashing, which is not ideal. Definitely pin 15 that I've got everything connected to. It is possible it's these wires. So let me just switch these wires about, just in case it's that. So some different wires here. So it looks like it's OBS that's decided to give up on my camera. I'm not entirely sure. I don't know if I can even change that while I'm streaming. Probably not. Oh yeah, I can. There's my other camera. It's like behind the scenes, that is. Oh, good. Now I'm back. Well, that wasn't as hard as I thought it was going to be to do that. So I'm just going to unplug these wires that I've got plugged in here, because it could be that they're not very good. So I want pin 3 on there, which is the ground pin. I'll plug this one in there. And obviously, if anybody can see something that I'm doing incorrectly, then do let me know. Because that should be running now and blinking. And in fact, I'm probably going to switch it back to pin 15 again, just to make sure that it's actually running. Oh, well, it isn't, because look. Oh, good. I'm glad you can hear me still. Because I've not saved it, so I need to save it. I'm going to save it as Blink 2. Ah, look! It's flashing. Is that working up there? I'm hoping it is. In the Twitch stream, it seems to be a bit delayed, so I'm hoping. Yeah, it is. Well, hey, there we are. Sorry about all of the messing around then, but yeah, maybe that's something to bear in mind. I mean, hopefully, I've not broken something over on my USBs over there, but probably just something to bear in mind. Probably don't plug stuff in while it's plugged into your computer. I mean, that's, I guess, the benefit of plugging it into a USB hub is that, you know, if you blow your USB hub up, buy another one for 15 quid or something. Not ideal, but way cheaper than buying a whole new laptop or a new Raspberry Pi. And by the way, I mean, I'm doing this all on a streaming setup here, so way more powerful than you need. You can do this all on your Raspberry Pi, and I mean, Raspberry Pi 400 would be ideal for doing this sort of stuff. So I do love that. Thonny, of course, it comes pre-installed on Raspberry Pi OS. So yeah, that's cool. So that's good. And being as I'm here, I might as well carry on. Let's have a look. What else can we do? We can add a button. I might go and get a button and just see what it does. I've got loads of those. So one sec. Hello. I've got a button. I don't know how easy that'll be to see, but these tiny little micro switch buttons, which is kind of what they've got on there. So it might be the best idea then if I wonder, do I need to click stop in Thonny or anything, or if it'll just well, there is stop, but I don't know what that's going to do. I'm just going to unplug it and see what it does. So there's that. I'm going to click that stop as well anyway. So if I plug this button in across. So the button's going to go across this barrier here. So you've got a line down the middle, and it's not great with my finger in the way. I'm just going to plug it in and then explain. So if I switch to this, you'll be able to see it a little bit better. So I've just plugged this little micro switch button in there across the middle, and so that will let us have a play with that. More wires for this, so switch back to this. Let's have a look what it actually says. So we're going to, oh okay, so they're going to use that rail there and that. Oh okay, so we've got plus, so that must be 3 volts that they've got there. So let's do that one. So that's here, and that is on pin 1, 2, 3, 4. Yeah, definitely pin 5. So that's going to be, that's 3 already, 4, 5. Obviously, be careful when you do this because there are 2 different rails. They're actually inverted, if you can see on there. So I'm going to plug that one in there. So that must be 3 volts going there. So we're going to be pulling the button up high to begin with, and then I've actually not got a resistor on the other side, so that's fine. And then the other side is going to go to the pin next to, I don't need to do this one. And this in there. More wires. Lots of wires. It's all good. Live electronics assembly. That's going to go in there. So that should be the button stuff. So if I plug this back in again. Good. I did hear the ding-did-a-dink happen, so that was good. Let's see if Thonny's done anything. Well, the run button's appeared back again, so it does seem to know what it's doing, so that's good. So we'd have added a button, just like it said, and the button's on pin 14, and it's connected to the 3-volt 3 pin on the Raspberry Pi, so that's what we thought. And this means that when you set the pin, you can tell MicroPython that it's an input, and this pin needs to be pulled down. So create a new file, and copy this code in. So you can do Control and N for new. So we're going to do the same thing where we're going to grab a pin, and we're going to use this time so that we can do this time.sleep and just wait for, I guess, half a second there. But if the button .value, so if the button has got a value, in other words, if it's high, I guess, then we'll toggle the LED and then wait. So it looks like if I'm just holding the button down, it's going to be toggling the LED. When you code, then press the button, the LED should toggle on or off. If you hold the button down, it will flash. Yeah, so that's exactly what I thought it would do. Oh, I can't get to Thonny. Oh, interesting. The screen went black there. Looks like it's still okay. So, all right, so let's run that. And I'm going to run on the Raspberry Pi Pico. And what did they want us to call it? Oh, it doesn't say. I'm going to call it button. Okay. Oh, unindent does not match. I think it's complaining about this, look. So, but there's nothing wrong with that. So maybe there's some white space there. Let's try that again. Right. Oh, that's interesting because it's still flashing the LED, which it shouldn't be. I don't think I've done anything funny there. So it looks like it thinks it's still connected down. Ah, that's because I had it the wrong way around. Don't know if you saw what I actually did there. I moved that black wire across to the other side of the button. So that's all I needed to do. So I'll try not to get my hand in the way while I do this. So if I press the button, then it's flashing. And we can press it once and it'll toggle it. So that's quite cool. I like that. That was quite easy as well. Obviously, I took the precaution of unplugging it and everything before I plugged anything in. So I'm not quite sure what I did there. And again, I'm hoping I'm not blowing my USB hub up. I was quite attached to that USB hub. Control the LED brightness with PWM. Okay, might as well do that. I'm going to carry on and probably till a about 5:30, and then I'll give up and everybody can go and have their dinner at that point. Or obviously, do feel free to sign off, and you'll be able to catch up on the stream at a later point, and it'll get uploaded to YouTube as well. So that's all good. So pulse width modulation. So pulse width modulation, it's kind of as it says. So you've got a little pulse, and it'll start at a low level and go up to a high level, or the other way around. And what you can do is vary the width of that pulse, and sort of the longer it's on, essentially, if you're doing the brightness of an LED, then the brighter the LED is going to be. Because what you're going to be doing is really, really fast turning the LED on and off. So that's what looks like we're going to do here. So we're the same circuit as the last step. And we've got a new file. So yeah, it looks like it to see these. I guess that's funny telling us that it doesn't like that indenting. So I'm not quite sure what is wrong with that code. But that's probably something that should get fed back. Maybe is that they might have some white space in there that they don't, that you can't see. So anyway, we're now importing PWM here at the top, and we're creating a PWM from pin 15, PWM pin on pin 15, which is our LED pin. It's kind of dropping off the top there a little bit, isn't it? And then we're going to set the frequency to 1000, and then which I'm guessing maybe that's 1000 hertz, a kilohertz maybe or something, or not sure. We need to look that up and see what that actually does. And then a duty cycle here as well. So that's the relationship between how long it's on and off, I think, actually. So you've got like a pulse width and an entire on and off section, and that would be that 1000. But then how long it's on would be the duty cycle, I think, or it might be the other way around. Obviously, feel free to correct me. We're waiting for our Pico to arrive, Helen says. So, yeah, my mate Cliff Aegis, he's awesome. He's an airline pilot, but he also, in his spare time almost builds robotic hands for children, and just a really, really cool guy. But yeah, I went down to W.H. Smith's first thing this morning and picked this magazine up with the Pico on it, and he's got the subscription, so he's still waiting for the postman to bring it to him. I don't know if it'll have arrived yet or anything, but hopefully yours will arrive soon. But I did order some from the Pi Hut as well, so that's quite cool. So yeah, so we've got some code. So let's save that and we'll run it on the Raspberry Pi again. Device is busy. Okay, so it looks like maybe do I need to stop this code? Is that what I need to do to make that happen? And let's try that again. Okay, maybe it is then. So call this one PWM. And it doesn't look like the LED is actually doing very much. Which you can see it on my image there. So let's just have a read. What's it say? See the LED pulse bright and dim in a continuous cycle. Well, we don't. Let's just try this. That might be the problem. Ah, there we go. Oh, look at that. How cool is that? The power of PWM. And as far as I'm aware, this is how those dimmer switches work on your wall there. But of course, they don't often work with LED lights. So back before we had these low power lights, when we had regular light bulbs, then you would do a very similar thing where you'd essentially turn them on and off, which is the buzz you can hear in those switches. So that's cool. So I like that. So yeah, we've got about 15 minutes left, so we might as well see what's next. We can control. Well, we might not get this far because I don't think I've got the part that we're going to need for this. Actually, it's explaining what this PWM is here. So the frequency, PWM frequency, tells the Raspberry Pi how often to switch the power between off and on, and the duty cycle tells the LED for how long it should be on each time. Okay, so I was right, but 50-50 chance. So for the Raspberry Pi Pico MicroPython, this can range from 0 to 65025, where that would be 100% of the time. So the LED would just stay bright, and a value of around 32,512 would be that it would be on for half the time. Have a play with the PWM frequency and the duty cycle values. So we can certainly do that. Yeah, pulse width modulation, absolutely. So yes, quite right. Thank you for pointing that out. So let's have a look at what this page says anyway. So I don't think I've got one of those hanging around. Let me go and have a quick look in my cupboard. No, sadly not. So yeah, but we can have a look at what it would have done. Yeah, here's what you could have won. So it's going to read the resistance of the potentiometer, and then you can turn the potentiometer and see the maximum and minimum values. So it's going to print it out with that line there onto the console. So we would have been able to see that. Yeah, that would have been cool to be able to try that. So I must go and buy myself some little potentiometers. I'm sure I've got one hanging around somewhere, but no one wants to watch me search around in drawers full of stuff trying to find potentiometers. I've got some big ones, but they're not going to work. Power your Raspberry Pi Pico. So can actually, so what's it say here? So if you want to run your Raspberry Pi Pico without it being attached to the computer, you need a USB power supply, which I have. I've actually got the phone that is providing the camera. Oh, tell you what, you probably can't see what I'm talking about. So, yeah, that would help, wouldn't it? Use the slider potentiometer. Yeah, that would have been cool. There's some cool stuff that you could do with this, actually. But yeah, I've got this little battery pack here, so we can actually power it from that if we wanted to, I guess. To automatically run a MicroPython program, simply save it to the device with the name main.py. Okay, then. So in Funny, save as. When prompted for MicroPython device, select the pop-up menu. So let's try that then for this one. File, save as. Raspberry Pi Pico. Devices, so I'm not. Does it actually say that anywhere in these instructions that you must remember to stop your code? I suppose, kind of goes without saying to a degree, but okay. So we should be able to save it as main. Press OK. So it saved it. You can now disconnect the Raspberry Pi Pico from your computer and use a micro USB cable. So let's do that. So plug this power supply in that I've got here. I don't see that running personally. In fact, it is possible that it's such a low power device that my battery pack can't even see it, which is entirely possible. What I'll do though is I'm going to plug it into. I'm going to try plugging it into my printer. My printer has got a USB socket, so let's see what that does. Well, the printer knows that I've plugged it in, but it's not running, so that sort of tells me that I've done something wrong. It's not the button that is doing something there. So, right, let me unplug that again and plug it back into my PC and see if I did something wrong. Ding-ding-ding. So let's just try saving that again. Oh, press this. Raspberry Pi Pico. Mains. I did do it. Or maybe, that's why. It doesn't automatically add the .py afterwards. So if I do that, I kind of half expected that to automatically start though. But I think that's the correct thing that I've done. So I've disconnected that. Let's try my power supply again now. Oh, there we go. So that's it running there without the PC. So I just needed to remember the .py part. I'm kind of so used to saving in these environments and it adding the necessary extension on the end. So so that was cool. So yeah, what next? Loads of stuff. Yeah, try out a few more components with the Raspberry Pi Pico, a buzzer, a light dependent resistor, or even a motor controller. Yeah, absolutely. There are people on Twitter that have already started doing that. So, and there is some more documentation here. And there is, in fact. So there's a getting started here for C++, which I might do at a later date. And then, yeah, here's the board specifications that we saw before and that pinout. So, yeah, I mean, I like that. That was really easy to get going with, and I like that onboard LED. I don't like the fact that it stopped working at one point, so I'm not quite sure what caused that, but that could quite easily just be my USB hub. Maybe it didn't like me fettling with some of this stuff there without with it being plugged into the computer still. That's possible. Not entirely sure what it was going on about there, but never mind. So thank you so much for tuning in. I hope you sort of enjoyed that, and if you've got one on order and it's coming, then good luck with that, and make sure to tweet out and let us all know how you got on with it, and any time at all, Helen. Thank you. It was good of you to tune in. I'll be uploading this to YouTube as well, so no doubt that'll get shared out at some point. But yeah, thank you again, and see you all soon. Cheers.